First thing before we start, something that we want to say. We're with Postman, and my colleague Mina here has created this wonderful GraphQL concept card. So we have a little game going. If you, after the presentation, we'll sign them. If you bring 2 or 3 of them to the Postman booth, you'll get a little special gift. So there's going to be other Postman speakers. If you can grab them, get a couple of cards or 3 cards, and then tomorrow at the end of the conference, if you can swing by, we have some goodies to give away. So, all right. Well, thanks for joining. My name is Pascal Heus. As you can see, I'm with Postman Open Technologies. Open Technologies is a group that at Postman that focus on open source communities, trying to make the product a better product based on what's going on out there. I joined Postman about 1.5 years ago. Prior to that, I worked for about over 20 years more in the data and metadata space. I was mainly working in the public sector, international organizations, national statistical agencies, and research communities in making data more accessible. So I've had a very strong focus on technology and metadata, putting knowledge around the data. And that's mainly some of the things I want to talk to you about. Today. So this is not really a GraphQL-centric talk, but I believe that GraphQL has a huge role to play in the data space, and I will define what I mean by the data space in my end. Because there's a lot of needs out there around data that drives the world, and there's lots of modernization needs, and I think GraphQL is hopefully a key component of that. So I'll talk a bit about data, talk a bit about metadata. By the end of today, you will hear what FAIR means, and it's not FAIR the word, but it's an acronym, and I'll just let you know a bit of what's going on out there. And we'll conclude by showing what I think GraphQL can do to solve a lot of data and metadata management problems that exist out there. So the first thing I want to define data from this perspective, because data can be many different things. And data matters in our world simply because this is how we measure how our planet is doing, how our societies are doing. This is how we make decisions on economy. So there's a lot of data out there that's being produced by government agencies, public sector, research, data scientists that basically are trying to see what's going on in the world and how we make this decision. So all these data sets that are out there are really used by decision makers to say, hey, are we going to invest in education, in infrastructure, in electricity? How are we going to reduce poverty? How are we going to basically drive the planet? How are we going to try to address the problem around climate change? So it's really data that drives the world. Every data set is important. But I feel what I call this real-world data makes a huge difference, and is it critical at the end of the day for societies and our families and this type of thing. So it's a bit in that context that I'm presenting here. And one of the major issues in there that I always claim is the data that is out there is really not data. We need more than that. One of the problems you'll find that a lot of the data that is being disseminated for such purposes is basically you'll find a lot of CSV files, data tables, SQL tables. And we look at that as basically as a bunch of strings and numbers. And these things haven't changed for a long time. If you look at the technologies being used, they come from the 60s, 70s, and 80s. We have CSV file, SQL. You may have heard of packages such as SAS data and SPSS that are widely used by statisticians to do data analysis with things like Excel. And these are really old packages, and not much has changed. We had NoSQL came over, and obviously plays a role as well. But you'll find that more of the data in that space has a tendency to be rectangular data that lives in database. And the problem when you get something like this, if I look at that collection of strings and numbers, there's not much I can do with it without the knowledge that what does that data mean? So it means, you may have a database schema, but it doesn't tell you what the data is about. So usually you need things like a code book, the classification, where is the data coming from, how was it produced, what were the questions that it asked. If you want to do useful research around data, or to make any sound decision based on this data, you need much more information than just this data set. And this is what I refer to as metadata. Because even if you find this information, you will have the tendency to find it in a structured format, emails, Word document, PDF, that are absolutely not machine actionable. So even as a user, you find this information, your machine still doesn't know anything besides these numbers and strings. So one way to look at this is we have a gap in this data information knowledge wisdom pyramid that is being used for many things. But if you can look at it from the data that lives at the bottom of this, and I said in database and files, and at the top we have data scientists, researchers, statisticians, analysts that need to try to do something useful with the data, or a machine needs to do something with the data. And we have that gap in between where basically first the information knowledge is not there. And then it's really hard to access because it's in files, and this is some of the problems we want to address. Because of this, there's a lot of data wrangling going on. Essentially, people spending time trying to find the data, turn it into something useful, or make sense out of it. And there's a statistic like a researcher could spend 60 or 70% of their time data wrangling instead of doing research. And that's a problem we're really trying to solve. And I think there's two things that are needed for this. One that you're very familiar with is APIs. I think APIs make data available remotely. It's much easier to work with. But there's also a knowledge gap, which is a metadata gap. And we're trying to solve both of this. So another way to look at this is you have data at the center, and this is what's going on today. You have these researchers on the left, and this manual data discovery, do a lot of data conversion, do a lot of coding around the data transformation to put it in the shape that they need. And that ends up costing a lot of time and money and resources. But this also equally affects machines. And so we have amazing computers today. We have AI. We can do amazing things. But this really limits the capabilities of software simply because they don't have the knowledge around the data. So there's a lot of human dependency where we have to code everything in. We have to a human needs to transfer all that knowledge to the machine because it does not exist in digital format. Now, a common way something we do all the time, we're starting to wrap APIs around data. And actually, there's not that many tools that do that. But now, of course, GraphQL came up, and that makes a huge difference in that space. But putting an API around data doesn't solve the metadata problem. So you can access the data. It's easier to access. I can query it, but I still don't know exactly what it is about. So it improves upon the situation. So it facilitates discovery. We have less wasted time. Machines can do a few more things with data, but it's still insufficient. Where we want to go into this world where we have basically the data comes with the metadata through APIs. And it's really trying to transition from that world where we produce data and we do the metadata and the APIs after, which is almost kind of a data first, API late, metadata late world, into something that is more, let's have the metadata and the data together available through APIs. In that space, if we can resolve this problem, then we solve a lot of things. Research can be more efficient, we have discovery, and then we can now empower the machine intelligence. We can unleash machine intelligence because the computers has access to this information in machine actionable formats. So just to elaborate a bit about metadata, because metadata mean a lot of things from different people. I'll give you a quick example here of what I mean by metadata. And it's not just a data dictionary, but for example, this is a data set, typically a file that you will find. You can actually find it on the web. You might know as a human, because you actually went this far, that this is the US General Social Survey, which is one of the most popular surveys used in the US to study the country population. But there's much more you need to know to do something useful with this simple data set. You may need to know, well, what is this about? It's actually people over 18-year-olds that live in households in the US. You see this little interesting column that says WRK stat, where it's actually the labor force status. Just to start working with the data, you may not want to know what is code 0, what is code 1, what is code 5, because if you just look at the ASCII file or the table, you don't know that. It probably sits in the document, but you have to find this thing. And you can keep going. An important thing, you may not know what the version is. An interesting thing, like we're doing research on 2 different versions of the data. We don't realize that. We get different results. We disagree with each other, not because we disagree, simply because we have different versions of the same data set. And you can keep going with this. Where does the data coming from? Who was it? Who produced it? How was it collected? And you keep going and going and going, and you'll end up with things like, which are much more conceptual in nature, like time, geography, and concepts, which is also typically we search for data. Like if I go on Google, I search for data, I'm going to type concept, and most of the time I'm going to ask a geography and time. So all these things are basically metadata, and there's much more to it. There's lots of documentation that comes with the data. There may be codebook, questionnaires, and all those type of things. And I said most of these things are actually hard to find and never in machine actionable format. So even if you're able to find these things, your computer will look at the data like this, because if you give a Word document or an email or some information that you got from somebody else, the computer is still blind and doesn't have access to metadata in API. So now how do we solve this? And most of people don't know, but there are actually many, many metadata standards that exist out there to document data. And actually, there's probably way too many of them. There's some website where you can go. There's metadata to describe data set, to describe provenance, to describe a lot of things. And there's a lot of them, but we'll find one of the reasons you don't know much about these standards is they've been kind of designed by data scientists and organizations that are not actually very technology savvy. So standards exist, but often they don't have tools, and they also don't have APIs, right? So we have two problems. We have a tooling problem, and then we have a too many standards problem. Now, there's a group right now that is coming up with, it's called a cross-domain interoperability framework, where they're trying to identify what are the 10 or 15 standards that we can use generically across all domains, across sectors to actually document data. I'm just going to put a list on the screen. I don't want you to look at that now, but later on, if you want to start to think, hey, maybe I want to use some metadata standard, this is a good starting point. Just click on any of the things. Maybe one that you might know is schema.org. I think schema.org is quite popular also, obviously, in the technology sector or amongst information technologies. But there's a lot of standards out there that are there to document data. And now how do we turn this into reality? So there's an initiative called GoFair. And FAIR is an acronym for Findable, Accessible, Interoperable, Reusable Data. There's a lot of organizations, data producers, data scientists, research institutions that have come together under the GoFair umbrella to say, what do we need to do to make data findable, accessible, interoperable, and reusable? So again, I'm not going to go too much in depth in FAIR. It's more to make you aware of the existence. FAIR is essentially a bunch of principles that I put together, and you can go on any of these principles. You can go on the website and look at each of them. But roughly, it's like if I have data, it must come with metadata. It must be well documented. It must be accessible in digital format. And a very important thing as well here is the idea of persistent identifiers. So whenever I have a data set, I should be able to have an identifier with it. But it's not only for the data. So the person or organization that created the data must have an identifier. The document must have an identifier. So persistent identifiers are very important to meet all these different FAIR principles. Now, FAIR introduced a bunch of other things like a verification process, like I have existing data, how do I turn into FAIR data? And basically, it's packaged it properly, adding metadata, put things like licensing information around the data and all these type of things. Again, this is one way to go FAIR. I'm sure you can have your own vision of this. There's also the idea of FAIR digital objects, which is basically I have something that contains data, but what needs to come with the data to make it FAIR? And essentially, it's identifiers, metadata, and make sure the data is available in open formats. That's kind of in a nutshell what the FAIR digital object might be. They have the idea of research object crates, which is, again, how do I package data together? Let's say I have a directory with like 50 files, which may be data, documentation, provenance. There's kind of a JSON format you can use to describe in a standard way what is part of that crate. So now I can open that crate and I know what's in it and I can figure out which part is the data, which part is the documentation. So there's also an interesting report that was done in the EU in 2018 about what is the cost of not having FAIR data. And we don't realize this, but what came out of this report is in the EU alone, there's anywhere from 10 to 26 billion euros a year that are lost for not having FAIR data. And multiply by 5 or 10% to turn that into US dollar. I think it's about, like by the time this talk is over, it's probably $500,000 that have evaporated because we don't have FAIR data. And it's simply because we don't disseminate data the right way. Simply because we don't give it away with metadata. Another problem as well, a big part of the loss comes in storage because I don't have access to API. Data is not behind API. I have a tendency to replicate it. And then the same data set gets copied 20 times. And you multiply the storage, and it's actually translated per-use cost. So, again, I put a list of references here if you want to learn more about FAIR. There's lots of things that are happening in that space, and you just can go and visit various websites, and I'm happy to talk more about FAIR after this talk. Now, besides FAIR, because FAIR is really something that, as I said, it's more managed by data custodian, data producer, data scientist, which is not partly an IT space. There's also something called data on the web best practices, which come from the W3C, which is very, very similar in nature. It doesn't have as much traction in terms of communities being around it. But because it's W3C, it might be a bit more technology friendly. So I think as an information technologist, I find it sometimes more accessible. So data on the web best practices is another way to look about, hey, I have data, I'm going to put it on the web. What do I need to think about? And you'll see that the recommendations are similar: metadata, unique identifiers. There's actually a few best practices around APIs. And so if you think FAIR is not for you, you can also look at the W3C, data on the web best practices. So all this to say is like, how do we turn FAIR into reality? And it's been a struggle for many years because it's been floating around, but we don't always have the technology. We don't always know how to do it. And the reason I'm here today is actually believe that GraphQL is the answer, because GraphQL can do a lot of things with data and metadata. So I wouldn't have gone through all this if that wouldn't have been the happy story in the end. And the thing we have to think about, though, is what I call the triple API challenge. And one, you're very familiar with this. The other two is usually the ones that I'm missing. So commonly, and this is a very simplistic picture of what it is, but we create data APIs. We have a data set, we put an API on there, and that's what we do all the time. This challenge is very well understood. But there's two more sets of API that needs to come existence alongside the data. And one is metadata APIs, and the other one is discovery APIs. And discovery APIs are kind of a subset of metadata API, but I put them apart because the first thing people do, you have to find the data. Where is the data that interests me? And when you go in that space, it's a little bit different because metadata is not rectangular SQL database type, but it's more JSON, XML, and RDF. RDF being typically the preferred format simply because it carries knowledge better. And so we need to add this metadata API and discovery API and create kind of these three API together will essentially deliver FAIR open data API. And these are often missing. Like if I may find a data set behind an API, but the metadata APIs and discovery APIs are often missing. So the traditional approach to do this is commonly I will have an open API definition, might be other spec, but I have open API, I have the data API. There's actually some platform that you can use to put open APIs on top of your SQL database, and there's quite a few solutions for this. Or you see a lot of people building their own APIs as well, which is costly and not particularly the right way to do it, but it works as well. Now, when you go to metadata, you could use an API, but you'll find other APIs like SPARQL. When you start to query RDF, you're going to use things like SPARQL. You may use Gremlin. You may use Neo4j Cypher. You may have a CouchDB database. You have MongoDB. And this works, but the problem with this, it's still quite complicated because now, as a developer or a user, I'm dealing with a bunch of different technologies. I'm doing the different API specifications. I'm dealing with different technologies. The world of RDF and SPARQL is completely different from I find the rest of the world. You'll find that if you talk to RDF and SPARQL communities, they mostly believe that RDF rules the world and everything should be RDF. And you have 95% of the rest of the world that never heard of RDF or doesn't want to use it. So this thing, it's possible to do it this way. And this is how people have been looking at this for many years. But it's still pretty messy. And the beauty of this is actually we have a much better solution. And this is where I see GraphQL being the magic bullet here. Because obviously we know we can put GraphQL on top of data. That's why everybody's here. We know how to do that. The beauty of this, of course, now you have an API specification that is data-centric. And whatever implementation I use, they're all using a GraphQL specification. It's very easy. But you can actually do exactly the same on top of metadata or discovery API. And there's two reasons for this. One is like all the metadata standards that I've talked about are a very good fit for GraphQL. They're XML specification, JSON. I did an experiment a year ago where I took one of the standards called DCAT to build data catalog. It took me, I think, a day with GraphQL Yoga to create a little mock API on top of DCAT. And now I can create basically data catalog using GraphQL. That was super easy to do. Of course, it was a prototype, but it's easy to turn actually into something more robust. The other thing I've seen emerging a lot in the past few months and year is GraphQL over SPARQL. And I've seen some, NPM JavaScript packages. If you look at some of the, I don't know if you're familiar with some of the triple store, like a Virtuoso as a GraphQL plugin now. So more and more now, you can actually hide SPARQL behind GraphQL. And I think that's a fantastic thing, because unless you're in the RDF space, unless you use SPARQL, you don't want to use it. Now, again, I can put GraphQL on top of these things. And now I have this unified dream where I can use one specification to be GraphQL. Not only I can do that, but I can also use the same to stitch data and metadata together. And so, which is ideally what you want. I want to be able to say, hey, here's my data, but by the way, here is the documentation of it. This is anything you want to know about the data comes along through the same GraphQL schema. And of course, you can build OpenAPI on top of it if you want to. And that's basically the story I wanted to share with you today, because I believe everybody at this conference here loves data. We have GraphQL to query data. And basically, I just want you to think down the road, like when I give data away, what else do I need to give? How do I get the documentation metadata that goes with it? Because we now have the tools to do that were not available a couple of years ago. And I really believe that GraphQL is the future of data management, simply because GraphQL can deliver both the data and the documentation, the metadata that goes with it. But we cannot ignore that aspect. Like, you should not give away data without documentation next to it, because it makes it really hard to use and to discover. So what are the next steps from here? But first, I'm here because I honestly don't know too much about GraphQL. I would like to learn more. So I have these 2 days of conference where I'm hopefully going to meet a lot of you and lots of different technologies and all this type of things. But I think the key is for me to bridge what I call the technoverse and the dataverse. I think there's a huge gap between the private sector and the information technology sector and all these agencies and research and data scientists that actually work with data. On one side, you have a community and a universe where technology is very well understood. We understand API, we understand how we can use technology and do magic things with this. But we may not know that much about metadata and data. And on the other side, you have the other group that says, well, we have data, we have metadata, we have fantastic thing. But if you go there and you mention the term GraphQL or even API, people may look at you as like, what is an API? Right? So I think bridging these 2 universes is very important. And there are ways to do this. There's a lot of places where you can go. There's a lot like this. There's a lot of conference around data and metadata. There's lots of research organizations where you can go and just talk about GraphQL and go meet the data scientists and the researchers and all these organizations that publish and produce data that actually make a huge difference in the world. And that's essentially what I would like to let's see going forward, is for these communities to come together. So I truly believe GraphQL is an amazing technology and an amazing specification to make the difference in the world. The question is, how do we weave these things together? How do we bring GraphQL with metadata, with GoFair, and how do we grow GraphQL beyond what it is today to actually being a complete solution for data and metadata management? And at the end of the day, I always say it's not about technology, it's not about setting up API, it's about making that data available that makes a difference in the world. So it's not even about data, it's about people, societies, or planet, and all the stuff of important thing, and it impacts our families. So it's not just technology. There's a story behind every data set, and there's people and other things behind every data set. So each time you set up an API, just think about this. As I'm putting an API, but actually I'm telling a story, I'm making information available that can make a difference in the world, and that's really, for me, what motivates me every day. So thanks for your attention. Hopefully, you can go and discover a little bit what is FAIR, what is metadata, what is data on the web best practice. I'm more than happy to talk to you about that. And I'm super excited to be here and learn more about GraphQL. So thanks for your attention. All right. Sure, absolutely.
The mic here, if you guys want to talk with the mic, so it's recording.
Thank you. That was a wonderful talk. I'm Ryan Abbott. I'm with NASA Earth Observation Systems. So I deal with this a great deal. I have a talk later today about our GraphQL implementation on top of our metadata API for exactly what you're talking about. One of the challenges that I continually face, though, is less about, so I think there's two things. It's less about making it available, and from the federal government perspective, it's who's paying for the egress of petabytes of data. And so we can make it available all we want to, but the government doesn't have the funding to just pay egress costs, which is a pretty big challenge. And then GraphQL, I think that there are great examples of where we can stitch schemas together. But once you leave a particular, even sub-science or sub-faction of a particular type of science, like earth science, the metadata fields and the information that you want to stitch together become very challenging. Yep. And that's where you get people discussing like, well, I want it like this and I want it like this. And it's like our keys might be called the same, but the actual underlying data is completely different. And so how do you provide both types of sciences with that key, but it returns a completely different piece of data? So I'm not necessarily asking you to do those things, but those are two challenges that, like, the conferences that I regularly attend are up for debate oftentimes.
Right, yeah, and I think that this is where this standard that exists actually can describe all these different situations, different data sets. And, but again, most people don't know about these standards. It's one of their weakness. And because they're not simple standards, it's not kind of it's not a data dictionary. It goes way beyond that. It will just describe all even how you can stitch data together, or what the conceptual relationship between two data sets. So it goes from the schema, but it grows to pretty complex space. I mean, if I show some of these standard diagrams, people will run away because they look like spaghetti. And they've been designed for over 20 years now, and I think since about 10 years they're mature enough. But one of the problems, there's two problems. One is the standards like tooling. The other one is to find the metadata, right? It's just because you're going to find all these documents, and how do I translate into machine actionable formats, or RDF or JSON? And that's one of the biggest challenges today. But there, I believe, I talked too much about that today, but I believe we can actually do a lot. We can actually automate, I would say, maybe 70% of creating the metadata using things like data profiling. The other option now that AI is emerging faster and faster, if you start to combine data profiling with AI and the ability to understand documentation, this variant structure, and turn that into these metadata standards, no, because that's typically the biggest standard. I mean, my whole story here falls apart if you don't have metadata in machine actionable format. And so I think there's solvable problems. The third one is also the one that you mentioned, is most of the agencies that manage this type of data are very slow to change. So you cannot go there and say, hey, you're going to use GraphQL tomorrow. Government agencies and a lot of research, maybe not research institutions, but most of the public agencies will take anywhere from 3 to 5 years before changing, right? So it's not something you can change overnight, but I think it's something we can see it, and bring technology like GraphQL. But we have to go and talk about it. That's really what it is, I think. Yeah.
Awesome, thank you.
Thank you. Yeah, for sure. Yeah.
So the new machine on the block is the generative AI models, LLMs. Have you thought about how some of these ideas can apply to generative AI?
Yeah. Well, but that's, again, I didn't talk too much about AI today, but I think one of the big questions around AI is where is the data coming from, which is another problem. So I think if you want, there's two things. If you want high quality data for AI, you need to solve this type of problem, because at the end of the day, data is what's going to feed your machine learning and your AI. And we got to solve some of these things, because otherwise you're going to keep getting in this issue about, hey, I have a model, but hey, where's the data coming from? On the other hand, you have using AI to fix this problem, right? And I think, again, it's fairly new for a lot of us. But I think generative AI can do a lot in terms of solving some of the data quality challenges, all the metadata challenges, also data privacy. I think I'm very interested personally to explore how AI can generate synthetic data, because a lot of the data set I'm talking about here are not public, and for good reasons, like especially if you go in the health sector. Could I use AI to generate synthetic data? Because generating synthetic data is very hard. So I think AI has many roles in this space. But yeah, from the AI perspective, is how do I get good quality data? Even where do I find data to train my AI, which is the first discovery problem, right? And so yeah, AI is definitely has a huge role from many different perspectives. And but I think we're still all learning where that can go. And I mean, it's starting to stabilize a bit now. You know, like 6 months ago, things were changing every 2 weeks. Now I think we're getting into a state where things are a bit more stable, and we can start to say, okay, I can build something on AI that's not going to change in 2 weeks, and you got to build solutions a bit more robust and long-lasting. But it's definitely a game changer. There's no question. Yeah, we got to start solving problems in a different way. All right. Well, there are no more questions. Thanks for coming. Don't forget, if you want a little GraphQL card, and again, you got to get something for the Postman booth, just come to me or just meet me at the booth, and I'll give you one of these slides, signed little card, and then come to the Postman booth tomorrow evening for the special gift, or afternoon, whatever we finish the conference. Thank you so much, and looking forward to meeting all of you. Just talk to me if any of this interests you. The data community needs you as well, so I will really encourage you to start to go and talk in some of these other conferences about GraphQL, because everybody needs to learn about that. So, thank you so much.